Hi there, this is Vahid from vrfEducation and welcome to my channel. Today we are going to take a look at gRPC, a high-performance and open-source framework developed by Google, and it's used for real-time communication between client and server. So you might wonder, why do we need to use RPC in general? RPC stands for Remote Procedure Call, and the G is also for Google Remote Procedure Call Framework. Why do we need to use that when we have REST? And it's used widely nowadays in web development, and we're all familiar with that, and it's very straightforward to use REST. So as I told you, gRPC or Remote Procedure Call frameworks used for real-time APIs, the thing that you cannot achieve completely with REST. And today we are going to see the difference between gRPC and REST and do a couple of examples to get the gRPC routine very well. So what is gRPC? As I told you, RPC stands for Remote Procedure Call. Procedure is somehow a method or function. They are the same in general, and we're going to call it remotely. The procedure is on other machine, so we are going to call it and send or pass some data or some parameters and get some responses. And it's developed by Google. So when something developed by some big companies such as Google, it's worth to use it and take a look at it to see if it's going to help us in our future development or not. It uses HTTP2 and also protocol buffers. It's very important to know that it's based on protocol buffers. It brings a lot of advantages over JSON in REST. And also, gRPC supports streaming. The thing that is really important to use in some web pages is streaming and real-time communication. And also, gRPC supports one-way streaming, such as from client to server or server to client, and also bidirectional communication. It's very important. And we're going to see how to use gRPC in a real chat application in another video. So please subscribe my channel to be aware when I release that video also. And also, gRPC gonna auto-generate some codes for us, both on client and server. You need to do some boilerplate codes. gRPC framework gonna handle this for us generously. So we will see, and we will talk about it later in this session. So let's see, what is REST? REST is an architectural style, and RESTful API somehow is the realization or implementation of that architectural style, and it's based on HTTP version 1.1. It uses JSON as its base messaging format, and it's text-based. It has some advantages and disadvantages, and we will talk about it in future slides. But it consumes more bandwidth. We will see very soon why. And also, it's widely adopted to almost every browser out there, and almost every programming language that we know nowadays supports REST. It works with standard HTTP verbs such as get, post, put, patch, delete, and things like that. It's very popular and it's very straightforward. And on the other hand, it's stateless. What does it mean? It means that every request doesn't have any information or any knowledge about the previous ones. So if you need to somehow depend your request to the previous request, you need to provide the data that the server needs to know about the previous request. And it also consumes more bandwidth and more data to transfer between the server and the client, and also more process on the server to know what happened before. We don't have deal with this one in gRPC. So this is the comparison between REST and gRPC in a table. The protocol they use, the format, and the speed, and the other stuff I listed here. You can review it and also search for detailed information on the internet. The most important thing is that the speed of gRPC is much faster than the REST due to JSON, because it's text-based and this is binary. We will see the protobuf features in future slides. And also, streaming. gRPC is developed for streaming. It supports one-way and two-way streaming, and in REST we have a limited support for streaming, and it's not also widely used. Most of the time we use is as somehow web API calling from client to server and get some response from the server. Well, it's the question for the most developers: when should I use gRPC? gRPC, just like all other way of communication between server and clients, is not the only choice. We need to know when to use it. In some scenarios, REST is the best choices. So when we are working or dealing with real-time data exchange in client and server applications, we need to use gRPC or a library or a framework like gRPC to transfer data immediately in real time. And also for some systems that develop in microservice architecture, gRPC can play an important role. Communicate between different microservices in real time using gRPC. It's very useful. And in general, when we are dealing with IoT and mobile applications, and we want to get information about something or some events happen on the other systems, gRPC or the framework that provide this feature for us play vital roles. And in this session, we are going to see how gRPC gonna work in Node.js programming language. The first step in using gRPC, we need to use a .proto file. This proto plays as a contract between server and client. Here we are going to define our services and the parameter format and also the response format. Here is a simple one. It's like a class in object-oriented programming. We have a service, the name is greeter, and here we have a method, an RPC method. We need to add RPC before the method, and I'm going to talk about it in detail in VS Code. Here we're going to provide the input data format, hello request, and we define it here by message keyword. And here we can define different parameters inside this request. And also it returns an object of type hello reply. Then also hello reply declared just like the input or the request structure. Here again, we can have different type of data inside this object. And you might wonder why we initialize this name field inside the hello request or the message inside hello reply. They are with the type of a string, but we initialize them with number. This is not initialization. This is the position of that field inside our data. Using this system, we don't need to provide the field name when we are transferring data or exchanging data. But in JSON, we need to do that. We need to specify the key. And omitting or deleting this extra information cause less size in our final packets. And it's going to cause less bandwidth usage. And the consequence is we are faster using gRPC. So make sure that we are not allowed to use primitive data like a string and things inside the parameter or the output. We need to pack them inside a structure or an object like this with message keyword. This is the declaration of the service and the input and output of the service. In the next slide, this is a very simple implementation for our service here. Let's say hello. Here we have two parameters, call and callback. Callback is a function on the other system that we need to call them remotely, and call is the information about the calling that happened. Here you can see we have the name parameter here that we declared here. We can access it through the request inside the call. And also the callback is the function on the other system. We will talk about it. We can call the callback function. We have two parameters, an error parameter, we don't have any error here, and the response. We can pass the response, the process that happened on the other machine, and some response produced, so we passed it back to the caller machine. So this is a simple call in gRPC in Node.js example, and we will talk about it in more detail. The simplest way that we can run an application is things like this. So before jumping into VS Code and do some practical example, let's wrap up the session or the slides with this slide, protobuf versus JSON. So as I told you, protobuf is very compact in size because we don't need to provide some extra data. But in JSON, we need to provide them, so we have a bigger package size. And also, due to this impact size, we are very fast in protobuf in compared to JSON. And also, as you saw before, we need to specify the type of the fields inside the request and response explicitly, but it's not necessary in JSON. It's not strict in JSON. And also, in schema evaluation, we are much somehow it's easier to do in protobuf because the position of the fields is important, not the name of them. So we can rename the fields without any consideration to the other machine. You can do it on your own, on your machine, on client or server. It's not important. But in JSON, we need to do it synchronously between server and client. They need to know about the field names, the keys, and the contract between them. And a drawback with protobuf, it's that it's not human readable because it's binary. So you cannot debug it easily. But in JSON, it's very common to debug it and output it on the console, so you can see what transferred between client and server, and you can debug it easier in contrast to in compared to protobuf. But in streaming, such as video streaming, we are not going to debug data in this way, so it's not important for some scenarios. But you can see JSON is better in debugging, I think. Now, let's get into VS Code and develop some simple applications in gRPC using Node.js application. First of all, we need to install Node.js on our local machine in order to be able to develop gRPC samples. We can visit Node.js official site, nodejs.org, and using install Node.js, you will be redirected to download the Node.js page. Here you can select the version, operating system, and the utility that you are going to use to install Node.js on your computer. I installed it already on my machine, and the version for me is version 22. And as far as I remember, you need to install Node.js version 14 or above to be able to work with gRPC. After that, we need to install this package at gRPC/gRPC-js. This is the main package that we need to use to work with gRPC in our applications. And as you can see here, we have a high weekly download for this package. And also, in addition to this library, as it claimed here, and again, we just mentioned inside the slide section that we need to define a proto file. We need to define what kind of services and what kind of messages and responses we have in gRPC. We declare them all inside the .proto file. And previously, we used a method named gRPC.load function to load this proto file, but it's deprecated, and we need to install also this library alongside with gRPC.js to be able to work with gRPC. So let's open VS Code and then open the terminal. And after that, I'm going to create a project with Wi flag to initialize the values with default values for me. And then after that, we need to install this package, npm install gRPC-js. And also, let me copy and paste it here. I'm going to install this one also, the proto loader. Well, yeah. So let's just paste the command and install these two packages together to work with gRPC. I'm going to pause the video, and after installing these two packages, I will come back. Okay, I'm back. Packages installed successfully, and the next step is to create our proto file. Inside the proto file, we're going to define general information about the services and also the input and output for every single RPC that we have. So I'm going to create a file named greeter.proto here. This file contains the information. First of all, we need to check this documentation for protocol buffer. As you can see here, we have a simple one. We need to start the file with this notation syntax equal to proto3. This should be added to our first line of the file. And it's a large document, and you need to be able, if the most part, if you want to have a good proto file. The thing here we have again, here we have a package, just like namespaces or packages inside other programming languages. It's going to help you to well structure your codes. And also the more important thing here is the type. This is the type supported by gRPC, and below shows you the equivalent in different programming languages. So we're going to use a couple of different of these types. So let's get back. Let's just make a copy of this one. I'm not gonna type it. So this is our syntax. And after that, I'm gonna create a package named greeter. We will use it very soon. And after that, I'm gonna say we have a service named greeter. We start the service name with capital letters in Pascal notation. And inside this service, it's just like a class. We're going to define some remote procedure call. Start with RPC, remote procedure call. And the first item that I offer service or remote call I want to add to the service is say hello. Say hello. And it's just like a method. It will accept an input and also it has an output. So uh, let's create those input and output. For each of this input and output, like data structures in other programming languages or like record in .NET programming languages, we need to define in this notation using message keyword the name of the structure. For example, here I'm going to call it hello request. It's the name of the package, the package, yeah, the parameters that I want to assign to this hello. So the input is of type hello request. What's inside it? We can declare some parameter here. For example, I want to receive a string and the name of the color of this service. And here I'm going to assign it 1. What's this? It's not variable initialization. It's like variable initialization, but we cannot assign number to a string. It's the position of the variable inside the data that we send to the service or send it back to the client. For example, if I want to add age, we can use int age, and this one I'm going to assign it with 2. This is the second variable inside this packet. Okay, got it? So we need to orderize the parameter input with this adding order to the variables. We don't need to specify the name of the parameters when we want to transfer them between our server and clients. But in JSON, we need to specify the name of the variable, the variables. So in here, we don't need to do that, so we can reduce the amount of data we transfer between our server and clients. And also, it's going to return something. It's going to return, and also inside the parentheses, we're going to specify the output or the return of this RPC struct. So again, I'm going to create another message. For example, hello response. And here I'm going to again here have a message inside it. It's a greeting message, and this is the first position of the output. So I'm going to return something of type hello response. That's it. This is our first proto file, the simplest one that we can have. We're going to enhance it during this session. Next step is to create our server. It's just like Express.js or any other web server that we created before with any programming languages. The server will be started and listen on a specific port for incoming requests. Now here we have a file named server.js. Inside here, we need to require those two packages that we installed before. So const gRPC, it's equal to require. You can also use import thing, but I'm gonna go with require inside this course. @ so gRPC / gRPC JS. And also I'm gonna import const proto loader, again require gRPC proto loader. And I'm going to use path module, const path, it's equal to require. So let's create a path to our proto file. I'm going to name it proto underline path is equal to path.join. It's inside the current directory, so I'm going to use dunder dir name, directory name, and append it with greeter.proto. This is the file path for my protobuf file that we created already. And after that, we need to load the package that we defined here, the package named greeter. So I'm going to say fast package definition is equal to proto loader dot load. I'm going to use load sync and the proto file saved inside this path. And after that, I'm gonna load the package definition. I just load the package here and use package definition. I'm gonna load the package of greeter inside this package. I'm gonna say I have a protocol here, proto. This is my real proto. It's equal to gRPC dot. We need to use load package definition and pass that package definition that we already created and specify the name of the package. This is greeter. This is the package name we specified here inside the server. Now, inside here, we have a service named say hello. This is just a declaration, and we need to implement it. We need to do something with this say hello. So I'm going to create a function. The name is say hello. This time it's started with capital S. Here, oops, not capital. This one is small. This one is started with capital S, but this one started with say hello. And inside the parameter, we have two parameters. One named call. This will contain the information client sent for us, and we're going to use it, and also some events that we can use call to communicate with the client, and a callback. This callback parameter will be determined by the client that after doing our businesses here inside the server, we are going to call this function to inform the client something happened, or maybe the data is ready so you can use the data. So I'm going to create a response here, response. I'll call it reply. Let's reply. It's equal to, I'm going to create, it should be something like this. Data struct contains a message variable. So I'm going to create, we have a message, and I'm going to use backticks here, hello. And inside the call, as you can see here, we received the name of the caller. So the client should provide us the name of the caller for us. So I'm going to make use of this one. Call.request dot name. You can access all these items inside this package from the request inside the call. And add exclamation mark here. It's good. And I'm going to call the callback. Callback function should have two parameters. First one is error. If something goes wrong, we need to inform the client using the first parameter. But right now, with everything is just go fine. So I'm going to pass null as the error and pass the reply. As you can see, reply has the same signature as this message here. So in our client, we can work with this reply things. So what is the next step? After adding the implementation for our service, I need to start the server. I'm going to create a function named main here. And after that, I'm going to calling this function. So everything goes inside this main function. We need to create a server. So what is the server type? I'm going to create a variable named server, and it will be instantiated from gRPC.server class. So here we created a server and we need to run it. But before that, we need to add the services to this server. So server needs to know what it should be sensitive for, what kind of services we have. So I'm going to say server.add. Here we have add service. So what is the service? Where is the service name? And also what's the package for that one? It's inside the proto, the variable that we created here inside the proto.greeter, capital greeter, this one, and add a service after that, service. This is a greeter service. So what is the real service name? I'm going to say we have a say hello service or RPC there, say hello. And the implementation for this one is this say hello function inside the server function, the server file. So this is our service, and we're going to add more services throughout the course. And here we need to start the server. There was a method named start, but it's deprecated. It's for older version. We're not going to use it. If you see it somewhere, it's used to start the server. But right now, we need to use bind async. I'm going to bind something to a port on my local interface. So for local interface, I'm going to LAN interface. I'm going to use 0000, and the port is 5050. I'm going to say, okay, listen on this port for any incoming request or call. And after that, we need to provide our credentials. So we don't want to use any SSL things right now. So we used to add, we are going to add gRPC.server credentials dot create insecure. We also have create SSL, but it's right now we use create insecure. And after that, if things go wrong or go okay, it will inform us throughout this callback function. We add an arrow function here. So if error happened, we're going to say console.error failed to bind. And after that, we'll pass the error, see what's going on, and we can just return. Otherwise, we're going to console.log server running is in on port. It will pass the port. If you can successfully open the port, pass the port to us, so we can print it on the console for the user. And that's it. So what we did here, we just implement our services or our remote calls, and we load the things like this, and also create a server, add those services to the server, bind it to a specific port on our local interface, and trying to start listening on this port. If everything goes well, we should see this message on the console. Next step is to create our client. They have both inside the same project. It's not a big deal, so we can separate them, but it's not important right now. So I'm going to create a file name client.js, and we will start the server after creating the client. The first part of the client is the same as the server, so we need to have all these inside the client. Both client and server need to look at the same proto file. Don't forget about it. Proto is the same contract between server and client. They need to know about things inside the proto. They need to look at the same proto. If you update the proto in the server, also you need to pass it to your client to have the same file. So after that, again, here we have a function named main. I'm gonna call the main function inside the client, and here we need to create a client variable. I'm going to call it client, and it's equal to. We are going to call the say hello inside the greeter. So I'm going to create an instance of this service and then call the say hello. Let's see how to do this. I'm going to say new proto. We just load the protobuf definition inside this proto variable. Proto dot greeter. Look, we are using capital G creator. This is the service, not the package. So this is the greeter, and it says, okay, what is the server address? We're going to say it's on our local host, port 5050, and also we don't have any credentials, so I'm going to use gRPC dot credentials dot create insecure. And that. So here we have a client object that we can use this one to add or to call information on our server. And also pay attention, inside server we use gRPC.server credentials, but here we use gRPC.credentials. This needs to be separate. That one is specific for server, and this one used for clients. So after that, I'm going to say we have a client. I want to call say hello from the server. And as you saw it here, we need to pass two parameters. First is call. We need to also specify the message request inside the call, and we need to provide a callback function. So I'm going to say I have a parameter. Let's see, what was the name? Okay, name. We have a name here. The value is, for example, Wahid, my name. And I'm going to provide a callback function. It contains two parameter, input parameter, an error or response. So server will be calling this callback function for me. And if error happened, go ahead and console dot error, the received error, and else is console.log. Inside the response, we know that the response is of this type. We have a message here. I'm going to say response.message. It is print a message for me. So, and this is the client side. Let's start our terminal and bring two terminal together. I'm gonna get this. Oh, in this window, I'm gonna run node server.js. It tries to start the server, so it's okay. Server is running on port 5050, and here I'm gonna say node clients.js. We're waiting. So as you can see, Wahid passed to the server, and the response returned. That is hello Wahid. So let's run it one more time. Again, server listen for a request on or an RPC call, an remote procedure call on 5050, and then it return the value. So this is our first gRPC program, very simple, but we need to do that to get familiar with this file and also how to run a server and a client. We will continue on more complex samples or more complex codes. In our next example, we are going to focus on streaming. We have two-way streaming from server to client and client to server. So this time I'm going to focus on streaming from server to client. Here I'm going to add another service to this greeter. A client will ask for a couple of different numbers, random numbers maybe, and I'm going to create a sequence of number and pass the number to the client, for example, with 1 second interval for each. So here I'm going to create, for example, I'm going to create a message. It says number request, and client will provide the number of numbers that it wants from me, the count equal to the first position. So it provides me a count number, and I'm going to respond to him through another message, number response. And here we have just one number. Let me say int order. We have an order. This is the first parameter, and in 32, the number itself. What's the number? This is the second position. What is the RPC called? We have an RPC here. The name is get numbers, and this time we accept a number request as we did before for say hello. But in return, as we want to stream from server to client, we need to add this stream keyword here, and the output is number. So number response. Now let's the next step is to implement this get number things. It's a little bit different from say hello, and yeah, we don't need the callback things because we're gonna emit some event, and client need to listen for that emit or for that event when emitted. So I'm gonna create another function, the function named get numbers, for example, and we just pass or we just receive the call parameter. Inside the call, let's extract the count. It's equal to call.request.count. And I'm gonna just return a number in order. I'm not gonna create random numbers. Check the code. The current number, it's equal to, for example, I'm gonna start from 100. Okay, the first number is 100, and I want to pass them, for example, in each number in second. So I'm gonna create an interval. Interval is equal to set interval. The delay between each execution is 1 second, and here if current it's also started with 1. I'm gonna use this code. If current greater than count, we need to do something. Otherwise, we're gonna use write method. Write something into this channel that created between the server and client. And I'm gonna pass an object. The order is equal to current, for example, current, and the number is equal to, again, current multiplied by 100. Make it different, and I'm gonna plus the current. This is my flag, or my condition to end the streaming. So if current is greater than count, let's do what I'm gonna clear the interval things and pass the interval that we said before, create this timer things, and call the end method, call.end, and this is the end of the transmission from server to the client, and return it. I'm not going to do anything. And also we need to add this service here. So I'm going to say, after say hello, we have a get numbers, get numbers, numbers, and the implementation for this RPC is get number, this one. So we have two RPC call or two services right now. Now let's move to client. Here, I'm not going to call say hello anymore. I'm going to comment it, but you have the code inside our Git repository. So this time we need to call client.get numbers and pass the number of items that we want. I'm going to say count equal to, for example, 5. I'm looking for 5 numbers. And this time, because it's a string, we need to save the output of the method call. So I'm going to call it call, and then here we need to listen for two different events, data and end event. So I'm going to say call.on data. If data received, it will pass an object of that number response for us. It's an arrow function, and we will see what we need to do here. And also we need to look for client dots or call end event, and inside the end we don't have any response, so we can just say console.log stream ended. But here inside this function, I'm going to say console.log order is something, and number so is response dot number, and also we should add response dot order here dot log. It's okay. So let's bring also back. I'm going to stop the server. We need to run it once more. Node server.js, and inside client. Oops. Oops. No. Run the server once again. Oh, it's okay. And run the client node client.js. So we're waiting. Order 1 number 100, order 2, order 3, order 5, and stream ended. So this is the way that you can create an streaming from server to client. Send a request to the server and listening for the stream. Again, we need to define the input and output packages using this message keyword and create your RPC. This time you need to add the stream keyword to the output or to the return section before the output type. Inside the server, this time we don't receive any callback. We just receive a call, and using write method and end method, we can control over our stream to the client. This is our business logic for this sample. And inside the client also, we call that service as our data and receive an object that contains on method. Using on, we are listening for a specific event, data event and end event. So in data, we receive the response based on this protocol, based on this package or extract, and we can apply our logic there. So this is the way that we use streaming from server to client. Next step is streaming from client to server. For client streaming, I'm going to add a new service to this project that wait for clients to send as much as numbers that he wants, and then calculate the summation and return it back to the client. So first we need to start from this proto file. I'm going to new RPC. The name is some numbers, and we have to define the input and the output package. So I'm gonna name it some request, and inside it I will receive the number itself, and for number or some response I'm going to create a package named some response, and the value is sum saved inside the sum variable, and the position is the first position of the packet. So the input is some request, and because we want to stream from client to server, we need to add stream before the some request or input parameter. And then I'm going to say it returns of type some response. That's it. So this is a proto file. And inside the server, again, we need to implement the set or some numbers function. Here I'm going to create a function named some numbers. And again, here we have two parameters, call and callback. Inside this function, first I'm going to create a variable named sum. It's equal to 0 at the beginning, and then just like what we did for streaming from server to client, we need to wait for events, data events, and end event here. So I'm going to say call dot on data. The input, I'm going to call the input request, and it contains the number. What should I do? I'm going to say sum plus equal to request dot number. Get the number from the request and add it to this sum variable. And on call dot on end, when the streaming end from the client, so I'm going to pass the result. So I'm going to say, again, we have a function here. We don't have any input, and we're going to call back. Again, callback has two parameters. First one is equal to error, so we don't have any error right now. And I'm going to pass the sum. So because the value and the name is the same, I can just put it inside the curly brace. So this is the server, and here finally I need to say some numbers equal to implemented by this function, some numbers. And that's it. So it's just enough for the server. Inside client, I'm gonna comment all these codes. Let's add a space here. So I'm going to say client. We created client before here. Dot call some numbers for me. Some numbers for me. Yeah, you want a call and a callback function. The call, because it's a streaming thing, I'm gonna use write method on that. So I just need to provide callback here. The callback function should a function with two parameter error and response. And yeah, if something goes wrong or went wrong, please return console.error. Print the error things. Otherwise, console.log sum it's equal to response.sum. And I'm gonna save the output of this service call inside a variable named call. And just like what we did from server to client, here we want to do opposite thing. I'm gonna go .write. Using write method, I'm gonna pass something to the server. So the input should be of this format, number equal, for example, to 5. And let's duplicate it, 15, 25. And finally, I'm going to call .end, just like what we did for streaming from server to client. So using this approach, I provide the callback for the server and also save the output of set numbers because it's a streaming function. Then I'm going to write some data to the server. And when it's finished, I'm going to call end to notify the server, okay, the data is finished. Go ahead and do what you need to do and send me the response. And then I'm going to print that response to the code. So let's run the server once again, not server.js. Also here, okay, server is okay, node client.js. Oops, what's happened? Callback. Error is not defined. Error. Oh, yeah, I'm gonna pass null, not clear the screen and run the server. Here also I'm gonna run the client once again. And after passing the data, it returns sum equal to 45, and it's true. If you not believe, okay, calculate these three numbers together, sum these three numbers together. So this is the way that we can create streaming from client to the server. Again, we need to create our input and output structure, create our RPC. This time we need to add a string keyword before the parameter input parameters. And inside the server, when we realize it, we accept two different input, call and callback. And we need to listen for events data and end event inside the call in this method. And when we get the end signal, we need to call the callback method that client provided for us. And then pass error and the response to the client. And inside client, after creating the client using Proto, we need to call that method or that service, providing the callback function and save the output of this method call or service call. And then using write method, we can pass data to the server. Now let's see. Let's see what how to do bidirectional streaming. It means streaming from server to client and client to server. For bidirectional streaming, I'm gonna create two different demos. First of all is echo server, that the client sends something to the server and server replied it to the server, and they just streamed it. And after that, I'm gonna create a chat application that server gonna broadcast a message received from a client to the other clients. So first, start with the echo server. I'm gonna create a packet named chat message. And here I'm gonna have a user. It's equal to the first position and a string message. And when server receives the message, I'm gonna fill the user part with server for this example. And in the next example, we will fill it with the sender real name. And here we have another RPC. RPC chat. I'm gonna call it chat. And because streaming is bidirectional, we need to have a stream keyboard both before input and output. So input is chat message, and also the output is the same because it's chat message. I need to receive something and send it again to the other part. Inside server, we need to implement that specific service. And here, because we have bidirectional, we just need to receive call parameter, and we don't have any callback because callback is for the time that we don't have any streaming. We just want call something to the client. And before I forgot, let's also declare it here. The chat RPC is implemented by this method. Now inside it, because it's bidirectional, on the server side, we need to again focus on two events, data and end. I'm going to say call.on data. We have a chat message. Message. And also let's duplicate it. Call.end. Then you also need to call.end to end the stream to the client, and we don't need to have any input parameter here. So first I'm gonna here write to the console.log. As the username. I'm gonna say it's the username. It's the username, and this is the message. So it should be chat message dot user, and this should be chat message dot message. And after that, I'm going to echo back it to the client. So I'm going to say call.write. This time I'm going to say, as the user, I'm going to change it to server, and for the message, I'm going to say, you said this message, that message dot message. And that's it. Nothing more. Now let's move to client. Again, I don't want to run this code anymore. This time I'm going to say I have a call again. It's equal to client.chat. Give it the client, and again here we need to listen for end and data also. And I can write something for the server. So let's see how to do this. I'm going to say call.on data on data. Again, we have an arrow function. Chat message. And I'm going to say console.log. And the message. That message that user, and that message that message. This is for that. And do what? Oh, and I'm gonna say call.write. I'm gonna write from user Wahid. message equal to hello, and also duplicate it again. This is me. And let's also create an interval after 3 seconds. Well, I'm going to call the end. And also let's say call.onEnd. Go ahead and also.log stream closed. So that's it, I think. And timeout. Setting turbo. The timeout after 3 seconds. Just call the end, and it's okay. Oh, let's bring it up once more. Run the server, and also run the client here. As you can see, it says Wahid said hello. Wahid, this is me. Server undefined, and also stream closed. Well, we have message, user, and message. Yeah, user and page. Okay. Client message of this one, and inside the server on end, let me also add console.log client is connected up to server. Run it once again, and run this one also again. So server, you said hello. Server, you said this is me. Stream closed, client disconnected. So we have this bidirectional, but the server again listening for new clients. If I run the client once again, you can see things happen again from the beginning. You said hello, you said this is me, and after 3 seconds, client disconnected and stream closed. But the server is running on the other side. Now, this is the simple one. And I want to enhance it and add support for multiple clients. When a client sends something to the server going to broadcast it to the other client. Let's see how we can do this. So let's close the terminal and move to Greater Proto. Let's also add a timestamp inside this package of int64 timestamp. I don't know. Yeah, we're gonna use it very soon. So I'm not gonna change anything inside this RPC. It's good enough. Inside the server. So before chat, I'm gonna say I need to save the list of clients connected to this server. And on any chat call, I'm gonna say client dot push add this call to the client. Okay. And then I'm going to say console.log inform the user new client add. Then when you receive the data from a user also printed to the console, and here I'm not going to send it back to the caller. I'm going to broadcast it to the other client. So I need to iterate over clients using for each. And each time I have a client to send data to, I need to use this code instead of call. Instead of call, I'm going to use client. Go ahead and pass it to the client, but not all the clients. I'm going to say if client, the current client is not equal to the call, it's not the client that sent the message, go ahead and pass the data to that client instead of the username. Also use and also this chat message dot that message dot user, and here as the real message. And also on the and on the end of the communication, we need to also remove the client from the clients list because it's disconnected. So I'm going to say clients dot splice using a splice and clients dot index of this call things and one. Find the index and just remove one item there. And after that, the communication will be. So this is the change that we need to apply here. I think we don't need to do anything else. For the client, first of all, I'm going to receive the name of the client, the name that user entered from the argument. So here I'm going to say we have a username. This is very simple. Oops, username it's equal to process dot arguments values. The third argument with the index of 2, or if it's not provided, use unknown. Then I want to ask user or client to enter some text. And when he press enter, the text will be sent to the server and server broadcast it to the other clients. Otherwise, if he entered or she entered exit, the client will be disconnected from the server. Let's see how to do this one. So I'm going to add another thing here, const read line is equal to require read line. I'm going to read something from the console and also I'm going to comment all this code. Then we will need to create the standard input and output for these input things and duplicate this code. I want to duplicate them so we can keep track of the codes here. So I call chat on data. I'm gonna say, and also we add a timestamp. Let's see what we did here with the timestamp. Oh, we forget to add the timestamp. So okay, I'm gonna say timestamp stamp with the smallest stamp. It's equal to chat message dot timestamp. Oh, we also pass the timestamp. And also add the username here called dot request dot call dot request dot username. Also pass the username or user, I think. Yeah. So user connected, waiting for data, log it, and that's. Let's get back here. So I received a message with the timestamp, and I'm going to create a time function here because timestamp is the number of milliseconds passed from the beginning of the start time inside JavaScript. So I'm going to create a new date object based on the thing that we received from the chat message. So I'm going to convert it to number, and as timestamp from chat message, timestamp, and here. And then I'm going to say, okay, convert it to local time string. Local time string. And here, time here, and then, oh, it's okay. So we also check for error. And here we can use process.exit. Get return from process also. I'm going to create the readline here. Const readline, it's equal to readline dot create interface. We need to create an interface to be able to communicate with the user. And we need to provide two things. Input, so it's equal to process dot standard stdin, standard input, and output it's equal to process dot std or standard out. Then I'm going to say console.log, something like this, start chatting, and inside the parentheses, type exit to leave. And then I'm going to say rl dot on line. If you read a line of input, please go ahead and run this function. I'm going to say if line dot trim, remove the space from the beginning at the end of the input, it's equal to exit to what? All dot end is coming from the server, rl dot close the readline and return from this function. Otherwise, it means after checking if it's not exit, go ahead and call dot write. Say user, it's equal to username. Message, it's equal to line, and timestamp, it's equal to dates.now. So I think it's also okay. Let's bring the and do what? I'm gonna remove one of them. Inside here, I'm gonna run the server node server.js. Yeah, it's okay. So I'm gonna create another command prompt here. So I'm gonna create 3 different clients. Where are we? Here. So ls. Let's also add another one. Also, I'm going to say inside here, please go ahead and node client.js user 1. Add mine. Press enter. It says what? Error, invalid client. Error event. Okay. Here we need to handle error on call. Call dot on error. I forgot about it. One. Error. And I'm gonna say console dot error. Add a couple of asterisks in the beginning and error.sh. See what we have in server is running, it's okay. Get back here, ls, and run the client once again. Try it. So it says server method handler cannot propose undefined reading user. String closed. String closed, why? Here we have user and oh, I'm not gonna delete. I'm not gonna write it here and after go Let's run it once again. Okay, unknown server request that user. Oh, because here I forget we don't have access to user right now. And let's restart the server. Run the server. It's okay, and let's get back to our client. So client. Oh, it's okay. Let's also move to the second client, node client.js. This time I'm going to call me now. And also for the third one, I'm going to say node client.js user one. But before starting this one, I'm going to start chat from Vahid. I'm going to say message one. So it says message one passed. Vahid says message one, the date is invalid. We're going to check this one. Let's check server. Inside the server, two client connected, and Vahid sent message one. Let's get back here, and I'm going to say message two. And we send it from Mina. Okay, we received message from Mina, and also inside the server, Mina said message two. Let's get back here for user one. I'm going to say message three. User one said message three passed to these two users, and also inside the server we have new client connected and also user one. And if we send message four from Vahid, message four from Vahid again, user one and Mina received this message four. Now let's check what we have. Well, what we did wrong with timestamp. We said what? We said we have a time. Yeah. That's because of this one. Oh, connect all. Oh yeah, let's also test /exit. I'm gonna exit. Okay, stream closed. Let's see if I pass message 5 here. Just Vahid received the message, and here we have client disconnected, message 5. So things are okay. Let's also run the server once again. And close. Let's also start with Vahid here, and this one with Mina. And let's just print a hello message. Yeah, we have the right timestamp here. So this is the way that we can handle two-way streaming with gRPC. So this course is getting a little bit lengthy, but I think it's worth it to watch from beginning to the end if you want to completely understand how gRPC works to handle data between server and clients. I hope you enjoy it. Please tell me anything that you need to know about gRPC inside the comment section, or any question or any opinion that you have the video. Till next session, goodbye.